Welcome to the webinar today. My name is Tim Stewart. I'm from Visual Decisions. We're here today to talk about a solution architect's guide to smart manufacturing with Ignition. With me, I have a couple of experts from Sandalwood Engineering and Ergonomics. Thomas, can you give a quick introduction to yourself and Sandalwood?
Yeah, for sure. Just want to say thanks, Tim, for having myself and Garrett here. We're happy to discuss this exciting topic here. Just a quick note. So my name is Thomas Stecco. I've been with Sandalwood now for going on 6 years, primarily working in the systems integration group. I work in various projects in digital transformation, smart manufacturing, IIoT, and cybersecurity, various platforms, and I'm happy to discuss this exciting topic today.
Excellent. Garrett?
Yep, as Tom stated, my name is Garrett Krasminski. I have been with Sandalwood for a little over 3 years now. I've been contracted out to various vendors to support data collection through different integration softwares.
Excellent. Let me get back to this view. We'll get kicked off kind of going through some of the blueprints and how we're going to approach this. I'll let you guys take it from there.
Yeah, for sure, Tim. So this is kind of a path here. We have a couple slides that Garrett and I kind of set up here for this webinar here. Kind of trying to go over our typical thought process when we are acquiring a new project or we're taking over an existing project. We always like to look at a path where we define, we select, where we architect, we integrate, and then we align. So this is the type of blueprint that we like to follow anytime that we're starting up a new project, just to get to a good base and a good familiarity with that project. And then we can always tweak it, but this is kind of the basic blueprint that we're going to follow and kind of how this webinar is actually going to flow.
I like to say that we try to begin with the end in mind, right? We don't want to just jump in and start architecting a solution right away. We have to really understand what the environment is, what the customer is trying to achieve, and kind of define what that process looks like, right?
Yeah, for sure. And anytime that we're starting out a project, it's always VPN connectivity. Is there an NDA? Is there a sandbox? Is there a test environment or a production environment? There's a lot of things that go into your project even before we can start building. And then when we have a solid foundation, we can get to the process steps a lot smoother and a lot quicker to get a better ROI.
Thank you, Thomas. Garrett, I think you had something to add there.
Yeah, Tim. So we view smart manufacturing as an integration of digital technologies, and this will lead to improvements in your overall efficiency of the line. So sticking to these set blueprints will help us improve your ROI and lead to a lot of improvements on the plant floor.
Moving forward, can you guys define as Sandalwood how you define smart manufacturing?
Yeah, for sure, Tim. So like when we talk about smart manufacturing, we're talking about more than just making the machines faster or smarter. We're talking about transforming the factory floor into a connected, intelligent ecosystem, right? So what is it, right? It's pretty much the digital transformation of the factory floor. And how it works is quite simple. We got to connect the machines. We got to gather data, analyze and transform that data, and present it somehow on some sort of a dashboard, right? Whether we're looking at trends or reports or advanced analytics, we need a graphical user interface so then we can show raw, meaningful data in a visual output. And really the goal here is to make the manufacturing process smarter, not just faster, right? And at the end of the day, the result that we're always looking for is less downtime, optimized production, and much faster ROI.
Excellent. Yeah, I mean, there's a bunch of definitions out there from different groups like SESME, which is the U.S. Smart Manufacturing Institute. There's the World Economic Forum created a standard around Industry 4.0 years ago and so forth. But I like the smart manufacturing term, and I think that it's pretty intuitive what we mean by it, right? Just how do you incorporate all these different digital technologies into your processes on the shop floor?
Yeah, really, it's not just about adding sensors or smart gadgets, right? It's about creating a responsive, data-driven ecosystem where information can flow from the shop floor to the top floor, right? Where we can get all the data right in front of the operators and the executives, which we'll talk about personas in the next upcoming slides, can get all those reports, get all the alerts, try to figure out where the bottlenecks are. Right? And this is what we really feel is the future of smart manufacturing for sure.
Okay. Garrett, do you have anything to add to that?
Connecting these machines and systems together on the plant floor and getting all that information to your end user is a really overlooked crucial aspect of manufacturing. Data is intelligence, essentially. So when you can look back on that data and make intuitive decisions and kind of cancel out those bottlenecks, you'll have a higher overall production rate. You'll see more satisfied operators as they can tend to downtime quicker. It just leads to an overall well-lubed machine.
Yeah, I mean, as you guys have said, the ultimate goal is not just to put technology on the shop floor, but to make manufacturing better, right? How do we improve the performance? And fundamentally, people have to do something differently tomorrow than they do today in order to drive that change. So let's take a minute and understand some of those different user profiles and who we're actually designing for and what we're trying to do for them.
Yeah, of course. So in order to correctly implement smart manufacturing for all the types of personnel on the plant floor, it's crucial that we get a good understanding of all the jobs and roles being carried out in your specific manufacturing process. So we account for all the roles on the plant floor. For example, we speak with the operators, and we get their input so we can design various HMIs and know what alarms, bells, whistles to configure. That way the operators can tend to those specific alarms on the floor. That way you're getting that real-time feedback, right? We also speak with the supervisors and the engineers, and they benefit heavily from smart manufacturing when they have a higher level or more detailed view of the line. They can configure and maintain and customize the system more efficiently.
Another thing to add is with Ignition, we can set different groups. So we can have the operators in a operator group. We can have the supervisors in a supervisor group. And then if we want to have some sort of alarms or alerts or some custom reports, we have the ability to fire those off to the correct departments, and we can customize those. So the operators don't need to see metrics about jobs per hour or like cycle time plus or minus, right? They just want to see how many parts that they've created per shift, the efficiency, and etc. And then we have the executives that want to see the KPIs, right? They want to see availability, OEE, productivity, and we have the capabilities and the flexibility with Ignition's reporting module, which we'll talk about in the next upcoming slide, to how it really affects the whole process from your operators to your supervisors to your engineers, executives, and et cetera.
Okay. Yeah, I mean, I like to think about standard work on the shop floor, and not just for the operators, but for anybody that's doing a task. Have them approach that task the same way, whether it's Bob or Mary doing that task.
Mm-hmm.
And by thinking about these user personas and how you want to structure the work for that persona, that helps kind of incorporate that standard work into the system and what you're providing for the different teams out there. So let's talk a little bit about Ignition and what are the right Ignition modules for doing these different things.
I'll take a stab at this one here, Garrett. So Ignition kind of works like a toolbox, right? You don't necessarily need every tool in the box, You just need the tools that fit your business use case. So that's what makes Ignition so powerful and scalable. So here at this example, we have two tables here. We have a chart on the left, which is your core modules, which might be your vision module. So think about any computer program, VLC player, Windows Media Player. If you have a legacy Ignition project with vision, you need a application on your computer to actually show all of your dashboards. So we use the Vision console and the Vision modules for that capability. Then we go into perspective where we have web and mobile-based applications where we can build dashboards all through your browser. Then we're looking at if we need communication and cross-talking with name queries, we look at the SQL Bridge module. And if we need any reporting or alerting, we can incorporate those modules as well. Then we look at on the right side, we have the custom modules or the additional modules that you can throw in that all fit into the four pillars, right? You have visualization, data, logic, alarming, alerting, and connectivity. So just like we have on the left core side, we can add perspective, vision, web-based, and reporting for the visualizations. Tag historians, web dev modules are also available if you want to store files locally on your PC and server rather than storing PDFs, JPEGs in SQL Server or something like that. If you're using Twilio or some sort of a text or SMS service, you have those capabilities and those modules through the Ignition toolbox as well. We have OPC UA, OPC COM, any enterprise, admin, serial type of connectivity and protocols, especially MongoDB if you're looking at a database approach there. But really the key takeaway here is you get to mix and match. You know, you start with the core modules and then add custom ones as your business needs evolve, right? So it's all about starting small. We provide a little bit of value and then we expand and scale once we get comfortable with the wins.
Yeah. So essentially, Ignition is providing this broad toolbox with lots of different things that you can utilize. And once you understand those user personas and the different needs that they have from previous in the discussion, then you're going to understand what are the things that you have to put in place, and that helps you decide which components for that toolbox you're going to pick out.
Mm-hmm. Yeah, exactly.
Garrett, anything to add to that?
Yeah, I just wanted to kind of touch base on or emphasize what Thomas said. This is not, Ignition doesn't act kind of like as a cookie cutter where you're going to build your manufacturing process around the modules of Ignition. Ignition builds around your manufacturing process. So as integrators, we can customize all these different interfaces, reports, alarms to custom fit your specific manufacturing process.
Excellent. So I think the next decision that a lot of companies come to during the implementation process is what to put on the edge, what to put on the cloud, and how you mix and match all of those different things. Can you guys talk a little bit about that?
This is always a tough question, right? And you have a bunch of limiting factors or a bunch of factors that you need to think about and decide what's best. Do we use an edge approach? Do we use a hybrid approach? Do we use a gateway, some sort of enterprise approach? So one of the biggest questions is where should the data be processed, right? And this really comes down to latency, bandwidth, system resilience, availability, and cost, right? So if we look at Ignition Edge, the real role of Ignition Edge is local processing and control. We can mitigate legacy equipment. Let's say if we have a old PLC or a remote terminal unit or a RTU, with Ignition Edge, we can have it communicate with MQTT protocol. And that's a solution that is deployed at the edge of that specific network. So the benefit would be low Latency, we can continue to store data even in a network outage. And one real good thing about Edge is it offers polling close to the device. So we're not polling from a SCADA application. This can be on premise as a data collector, which can also publish data centrally once it's back online. So this adds IIoT to your SCADA system. When I look at the use cases, like when would I want to use an Ignition Edge platform? I think it would be best for a lightweight application with legacy equipment that might be remote or have very poor network connectivity. So if we lose internet or we have low bandwidth, we can store data. And once the connection is back up, we can send that data back to the central server. And that's really, I would think would be the best approach for a sole Ignition Edge application. What we typically see with a bunch of customers that we've worked with is just the plain Ignition gateway, which is the gateway processing. So here it's really centralized aggregation and analytics. So the benefit here would be enterprise-wide insights that are scalable across various clients and devices. And it's really best for complex SCADA and MES systems. If we mix the both of them together with Edge and Gateway, we have a hybrid approach, which is typically recommended because we can utilize both Edge and Gateway architectures. And the beauty of this is we can handle immediate critical control. So the Gateway manages the broader coordination and analysis, which in return makes it a more resilient, cost optimized, and flexible approach. But again, it just depends on cost, scope, and what really the project or the assembly might look like year over year, right? So we always start small, and then we can build upon that with all the tools available with inductive automation here.
For me, a quick summary of that is, you want to manage risk of having the network go down, and have the capability of still running with the edge device there and so forth. But you also want to have the efficiency of having that centralized point where all of the data is being processed and so forth. And so how you balance those things out, comes down to cost, comes down to latency requirements, and other technical factors that are going to help drive that decision.
Exactly. Yeah. Exactly.
Okay. Another key aspect of that same decision, as well as just overall, looks at designing a scalable solution. So can we talk about that a little bit?
Yeah, for sure. So scalability is what enables growth, right? It's not just about solving today's needs. It's about building an architecture that can expand, adapt, and integrate with whatever comes next. So here we have an illustration of a single gateway, scale out, and hub and spoke. Each have their pros and cons, obviously, but whichever approach you choose always looks at the path, right? And which path we want to follow. So the single gateway is best for a single production line, a small plant, or a pilot project. As an example, would be like, let's say we have a corn husker or some sort of a farming application where we have one line, and we just want to do a test to validate if the data is meaningful and is useful. We can just start out with a single gateway and then expand. The scale out is taking that approach and then building it on where the multiple gateways share the workloads, almost acting like a load balancer. So here we can improve performance and reliability. So as a good example would be, as more and more production lines come online, we can add additional gateways to distribute the workload without re-architecting that platform, right? The last one would be a hub and spoke, where we have a central server or a central processing unit that's taking all the data from all local gateways and transforming that data and acting as a master hub. So if we have a huge plant that might have 5 or 6, 7 sister plants, we can have a central server that's consuming all that data from all the single gateways, and then acting as a hub and pushing out the data to all of our dashboards, reporting services, and etc. Right? So whenever you're running a single pilot line or coordinating dozens of facilities worldwide, the principle is always the same. We design for today, but we plan for tomorrow. And this is kind of the approach that we like to follow.
Okay. Garrett, anything to add around scalability?
Yeah, of course. I think this slide kind of highlights the versatility of Ignition, from your single gateway to scale out architecture to the hub and spoke model. It's important that you can ensure that your system stays resilient and it always has room to scale for the future, right? And Ignition kind of embodies all of that at once.
Okay, excellent. Another key thing as we start to look at different systems and putting a solution in place for customers is how we integrate the information from the shop floor with additional systems. So let's talk about that a little bit as we take the next step here.
Right. Yeah. So this diagram shows pretty much how Ignition breaks down the silos by unifying data across all the layers of the manufacturing. And when we look at this diagram, we start at the bottom, our bottom layer, which is our device layer, and we work our way up. So our typical device layer will have our PLCs, our RTUs, any field devices that generate raw telemetry data, right? And then that data is processed via open standards like OPC UA or MQTT, PubSub, publish and subscribe services, right? So here an example would be a older PLC that's running on a packaging line that can still feed data into the system once it's exposed through OPC UA. And then in the middle layer, we have the edge or the gateway layer. And this is where Ignition bridges the operation and business system gaps. So here Ignition is going to aggregate and conceptualize that data, which can be used for reporting and displaying our information through various dashboards. And this provides resilience and store and forward capabilities. So let's just say, as an example, again, we used this in the past. If the network drops, we can use Ignition Edge to keep local control running. And once the connectivity is restored and synchronized, so we can push the data back into the gateway. Then we move to the very top of the layer, we have the enterprise layer, right? And this will be our ERP system, our CMMS, our analytic tools that are consuming and transforming that specific data. So here, this is typically used for planning or quality control or specific decision making, right? So let's just say we have a team in maintenance that gets a report from the computerized management system, right? And they can get a report on various downtimes, how long a machine was starved for, or how long the specific cycle time was, and etc. So then you can use those tools to predict preventative maintenance rather than changing the gearbox oil of your robot every 6 months, because that's what is stated from the manufacturer. If you can look at the raw data and maybe push those envelopes to 8 months, 9 months, because you see the specific data and you see the integrity of your process, it lets you make much more better specific decisions where we can increase that ROI, right? And this is very, very important when it comes to getting data and making that data work for you, right?
Yep. Yeah, I think there's a ton of use cases where you're looking at information across different systems, right? So just as an example, everybody does some form of preventive maintenance, whether it's just changing oil or more advanced tasks than that. And you're always wondering, am I doing this too often? Am I not doing it enough? And between the CMMS and the information that you're collecting from the shop floor, you have information to run that analysis to say, am I still seeing failures that the preventive maintenance is supposed to be addressing? And if so, I might need to do it more often. If I'm never seeing any of those failures, then maybe I could extend the time between that maintenance task a little bit longer until I start to see some failures as a result of that. And then I know that, okay, I need to run it a little bit more frequent than that. And so it allows you to do that experimentation with data that you just didn't have access to previously.
Yeah, for sure. Like if you're in a manufacturing environment where you have like a summer shutdown or you have like a winter shutdown, you typically do all your maintenance in those intervals. But with the data, we can make trend charts, we can analyze that specific data and get a better idea of when is maintenance actually required, maintaining the warranty, obviously. That's the beauty of that specific data is it provides a single source of truth, right? So everyone is working from that same data set. We're no longer siloed with data in Excel, data in SQL, data in Access. Everything is available in one single source envelope, right?
Yeah, and another thing that companies, have been trying to do over the years is to push decision making, down further in the organization, right? So, how do I do autonomous maintenance? How do I support operators, making those decisions and so forth? And to do that, you not only need to provide them information about what's happening within the process, because they're running the process, they have a pretty good idea of that stuff. But you need to be able to provide them that contextual information from those higher level systems and present that within their UI as well. Garrett, what are some additional thoughts that you have on the topic?
Yeah, so I mean, we see this as a very common issue on the plant floor is, for example, wear and tear on tools. We were working for a previous vendor and the CNC bit on one of the robots was starting to wear down, and they actually had a set schedule where they go in and maintenance that specific CNC bit on a bi-weekly basis. But analyzing that data using OPC or message querying to drive that plant floor data up to the enterprise layer, we're able to actually narrow down that maintenance schedule. And, that's less time you need maintenance there. That's more efficient data. And you got to look at it as data is not just numbers, it's valuable insight. And that's going to end up saving you money.
Yep. Excellent. Speaking of money, another big topic for us to look at is how do we align all of this technical decision making with the business value? Because again, that's ultimately where we're trying to go with this.
Yeah, so every technical decision must serve a business goal, right? It's not just about what's possible, but what's profitable, right? So here we want to reduce costs, improve quality, accelerate time to market. Key examples of reducing costs would be with rapid development, right? We can automate tasks, we can create named queries. When we're building our dashboards, we can utilize templates and template repeaters. So instead of creating 100 widgets of a particular machine, you can create one template with incorporating a user-defined type or a UDT in Ignition. We can use parameters to set machine num to 1, set machine number to 2. And then we can create scripts and build out those layout views quite quickly, right? And the way we improve quality is with real-time monitoring and analytics, which allow us to catch those issues quite early. The beauty with Ignition, and depending on the core module that you pick or the advanced modules, right, we can stage these rollouts piece at a time. We don't need to wait for the full project to be completed to actually deliver it. We can get immediate results with just a couple of days of development based on the complexity of that specific project, right? So as a good example would be preventive maintenance, right? Where we get real-time data, and based off of that data, we can figure out what those KPIs are, where we can reduce downtime, where we can reduce equipment failure, and extend the equipment life. And if we can extend the equipment life, we can speed up the ROI, right? So like when I think about Ignition, it links your technical choices directly to business impact, right? The goal is, every decision maps back to cost, quality, meaningful data, and time to market. If we can deliver a product within a matter of days, and management can see the improvement in production, less quality alerts, and et cetera, it just makes everyone happy from the shop floor to the top floor.
Garrett, additional thoughts?
I think he nailed that one. I mean,
All right.
Really.
Yeah, certainly for me, with my work, with the Sesame road mapping process and so forth, I have a really strong focus on how do you actually drive that business value. And Thomas, as you were talking about, you really have to think through for these different solutions how that ties in. And one of the things that you talked about that I really liked was the ability to have a quick win and really start to drive adoption, start to build the momentum for the overall implementation by putting something in quickly that helps you drive immediate value. So something like predictive maintenance, you have to build up enough data over time that that data store has predictive value. But while you're doing that, you can start to look at condition-based maintenance, where you just set up a tolerance and you say, hey, if this variable goes outside of this tolerance, then I need to look at what's happening with the machine. And you can set that automatically. You can set that using some math, if it's outside of 2 standard deviations or something like that. But there are things that you can do in the meantime while you're building up enough data to do the predictive maintenance to still get that quick win, to still get that value from the solution that you're putting in place.
Yeah, for sure.
So why don't we switch over and start to talk about some of the lessons learned and some of the best practices that you guys have seen.
It's really about the execution here, right? Like you just mentioned, starting small. Pilot projects have to prove something, right? And like you mentioned, they do deliver quick wins, right? And they build momentum. If we start small and the consumers, the operators, the key decision makers like what they see, we build momentum into phase 2, phase 3, and phase 4. One of the most important things I found is engaging the stakeholders early, right? Involving the operators, the guys in maintenance, the IT guys from day one. Their buy-in and their insights are critical in generating meaningful data that actually makes sense. Or, when I get a report, I like what I see. It's not just fluff. It's data that actually improves that specific process, and really investing in the people, training. We can turn hesitant staff into power users, right? And if those users are comfortable with the tool, they can bring new ideas that can be added to the project, right? And then we plan for scalability. We build with today in mind, but we design systems that can grow and adapt for tomorrow, right? So we like to typically follow the specific blueprint. Start small, engage people, we train well, and we plan for growth.
Sounds good. Garrett?
Yeah. We don't want to overwhelm anyone when we come in and start an addition project for you for systems integration. So definitely start small. We can grab one small line, for example, just a small CNC line. We can grab that, drive that data to a specific single gateway. Start small, have a central hub for all your data. We can start customizing reports for you, and start just giving you small samples of what Ignition can do. And then as you kind of get the gist of it and get more familiar with it, of course, we engage people, we can train them. And if, you get comfortable, and once you get that exposure, then you can eventually plan for scalability if it meets your needs.
Excellent. One of the lessons that I've learned over the years is working with Sandalwood. gives you a really good chance to actually have success. I've seen customers try to do this on their own, and they know their manufacturing process very well, but they don't necessarily have all the skills internally to turn that understanding into a solution that's going to help them evolve that process going forward. And so working with a company that has the experience that you guys do of laying out what that process looks like to not only understand the current state, but then also design that future state and make that a reality is something that not a whole lot of people can do. And working with experts like yourselves significantly increases your chances of success going forward.
Yeah, for sure. You made a good point there, Tim. Like anytime we're creating name queries or we're creating dashboards, it's all about the naming convention, right? Is if Garrett's never seen the project and he opens up the Ignition Composer, the Ignition console, will he navigate and be able to follow what's currently in place, right? And this is huge, right? Where we have everything named correctly, everything looks the same, everything is in folders, so it's easy to follow. It's not super complex. So once the project is handed over, the new developers can actually take over and not have any issues, right? This is clutch.
All right. With that, I think that we are here at the end of our presentation. If you have questions in the audience, please reach out to us. The contact information is here on the screen. Best way is probably either email or call us, but you can also go to the website. There's a contact form on the website that you can look at. And hey, if you're local, you can stop by, I guess. Other than that, Garrett, Thomas, thank you very much for your time today. I appreciate you showing up and look forward to talking again in the future.
Thank you, Tim.
For sure, Tim. I'll talk to you soon, buddy. Thank you.